Hello everyone, I'm going to demo about the WaterGuardian platform. First, I log in into my Arctic board to monitor the memory usage. Then I log into the Arctic board again and start the Meteor framework. Meteor framework is a web framework that able to localhost the WaterGuardian website, and it is free and open source JavaScript web framework that is written using Node.js. However, Meteor development is not yet official in ARM v7 dev board, so I use an unofficial Meteor repo developed by a group of volunteers called For Commerce Technologies AG. It works pretty much the same, just that I encounter some problem during this development, but it is okay, so I have no choice to do it manually using the call function. Now I will speed up the video because it takes up a couple of minutes before the website gets hosted locally. So now it is hosted at port 3000. We can browse the WaterGuardian locally with Arctic board IP address and the open port. So this is WaterGuardian login page. Now I need to create a new account to use this application. During the first time login, there is no data, so the dashboard display is still empty. Because I allow the browser to use my location, it will know my coordinate point and display my location weather data. The water consumption pattern, consumption forecast, display bar, and current goal is still empty. Next, when we click the weather forecast tab, we can view the full weather forecast data. We can view the forecast within 24 hours, temperature pattern, and forecast report within 2 days. All of this weather data is from forecast.io, which is a global weather service website. Next tab is consumption calendar. In here, we can view our water usage in calendar mode. However, now the display is still empty. In the next tab is water goal. Here we can set the water goal. All of the water goal unit here is in liters. So if you enter the overall water goal, it will divide the water goal between my water closet, bathroom, and kitchen equally. In this case, I enter 1 liter for overall water goal. Each of them will get 0.33 liter. So now I'm going to set my email notification. As an example here, I put my email. If next time my water usage have exceeded my water goal, WaterGuardian will send an email to notify me about the warning. In the last tab is API calls. WaterGuardian Platform is a RESTful model. In order to let the sensor data to be input in the WaterGuardian Platform, I need to set the correct device ID and device token in my Arctic C program file to pause the water flow data. In the C program file, I must make sure that the IP address and the port is correct. And then I need to set the device ID and token appropriately from WaterGuardian Platform. After that, I need to compile the C program with GCC. Because the code is using curl function and threading, I need to include the external library flag. After compile, I will get the execution file which I can run it, and I include 16, 21, and 22, which is the pin 11, 12, and 13 from Arctic 10 to read the water flow sensor data. When the program is running, it will keep printing the status of the valve for water closet, bathroom, and kitchen. Now I can control the respective valve remotely. All of this control is in real time. Unfortunately, it crashed soon after it connects. I guess this is because of the unstable version of unofficial Meteor that I use in Arctic 10, and this really need to take some time to debugging it. However, this does not stop me for this demonstration. In the next scene, I will do it manually using the curl function. Now I need to open up a new tab in Terminal to do curl function. I can go to the API calls tab to copy the terminal line from the pause example. I set it to water closet, let's say 0.05 for the water data, and the same for the flow rates, and then for the hosting address. Now in the real-time monitoring tab, I set the configuration to 10 seconds, which means that it will show and display the latest data within 10 seconds and start it. Start the water flow to accept sensor data. Oops, I have the extra HTTP typed in my command line. Now I have to remove it. Now I should be able to run it successfully. Okay, now you can see the platform is receiving the data. I will keep posting the data so that you can see the data is acting in real time. Okay, now let me change the water volume so you can see the difference. So when the consumption is exceeded the water goal, which is 0.33 liter that I said earlier, the platform will show the alert notification and stop the valve. This is to prevent any water flowing. At the same time, you will send an email to my email address. Let's refresh the page. Okay, now you can see this is the email from WaterGuardian Platform. This can be done because of the Mailgun API that I use. Now I will head back to the platform and repeat the same process to the bathroom, and make sure to change the location to bathroom in call command. The same process will give the alert notifications and alert email. So now let's go to the dashboard and refresh it. You should be able to display the consumption pattern. So when the water flow data is received by the platform, the dashboard will also react in real time. In consumption calendar, all data will be recorded and organized properly. If we click into the consumption bar, in today's date, it will display the location total usage, average water flow rate, and the total duration gap for consumption. The last step for introduction is data logging. All the sensor data will be recorded here, and this page will also react in real time. Let's say if I insert some sensor data, you can see it update in real time. So next time if I want to use more water and disable the alert notification, I need to set and increase my water goal again, so that I can use water in accordingly to prevent waste. So this is the end for the demonstration of WaterGuardian platform. I believe this platform able to give awareness to users to be more cautiously when they use water every time, analyze how much of water they use every day, and react smart for every drop of water they use. Thank you.